Cervical vertebrae. The cervical vertebrae from C1 through C7 are the most variable of the vertebrae. This variability is due to the fact that the general structures of the first C1, which is atlas, and the second C2, which is the axis vertebrae, in this region is modified significantly from the structures of the remaining 5 cervical vertebrae. The cervical vertebrae form a delicate column of bones that vary considerably in the range of mobility at their joint surfaces. The vertebral bodies of cervical vertebrae are interlocking with saddle-shaped superior and inferior surface, which are smaller than those of the thoracic vertebrae. So their location are at the most proximal part of the vertebral column. And for the first one is the axis. Cervical vertebrae. The cervical vertebrae from C1 through C7 are the most variable of the vertebrae. This variability is due to the fact that the general structures of the first C1 and the second C2 vertebrae in this region is modified significantly from the structures of the remaining 5 cervical vertebrae. So C1, which is the atlas, we shall check on that later. C2, which is the axis, have different structures as compared with the rest. The cervical vertebrae form a delicate column of bone that vary considerably in their range of mobility at their joint surfaces. The vertebral bodies of cervical vertebrae are interlocking with saddle-shaped superior and inferior surface, which are smaller than those of the thoracic vertebrae. The first one, which is the atlas, you can see it's quite different from the rest. Then axis is also different only for a few structures, which includes the dens or the odontoid process. These are the facet articulation with occipital bones to form a joint known as atlanto-occipital joint. The location of the cervical vertebrae along the vertebral column is at the most top or the proximal part. These are the remaining cervical vertebrae, and they have at least spinous process with typical features, which is bifid or divided ends into 2. So the typical cervical vertebrae with us here, which we have the body, transverse process, vertebral foramen, lamina, bifid spine, articular process with facet articulation with adjacent vertebrae. Then we have the transverse foramen for vertebral artery. Then say the vertebral foramen. On the description part, however, the vertebral arcs are large and wide relative to the vertebral body. At the root of the cervical arc and on either side of the cervical vertebral body are transverse foramina medial to the transverse process. This foramina houses the vertebral arteries that passes upward to the posterior part of the brain. All cervical vertebrae have 3 foramina, 1 vertebral foramen and 2 of the transverse foramina. The vertebral foramina of the cervical vertebrae are the largest in the spinal column because they house the cervical enlargement of the spinal cord. Yeah, these are the distribution of cervical vertebrae starting from C1, C2. You can note the enlargement of the vertebral foramen, while as it goes down, it begins to narrow, and you can as well identify the transverse foramens. Yeah, this is C3, C4, C5, C6, and finally C7. As well as the spinous process for the C1 is much or quite short, and it can be just but a tubercle of a bone, while for the rest are at least elongated. The spinous processes project fairly horizontally behind the vertebral body. Those of C2 through C6 are often bifid, that is, at their tips they are branched into 2 small projections. Transverse processes are very small, single or paired tubercles that project laterally beyond the transverse foramina. The first 2 cervical vertebrae differ considerably from the others, as said before, which is atlas being C1, lie between the cranial or the cranium and the axis, is a ring of bone with anterior and posterior arcs and large lateral masses. It lacks a vertebral body and a spinous process. The superior surface of the lateral masses, called superior articular facets, are concave and articulate with occipital condyles of the occipital bone to form the paired atlanto-occipital joint. These articulations permit the movement seen when moving the head is nodded up and down. The inferior surfaces of the lateral masses, the inferior articular facets, articulate with the second cervical vertebrae. The transverse processes and transverse foramina of the atlas are quite large. So this is the atlas, then we have the axis down here. And at least along their surface, there are few description, as for instance, the part labeled on the anterior arc of atlas with anterior tubercle right here. Then 2 is the superior articular facet of the atlas. 5 is the posterior tubercle of atlas. Then we have 6 dens or odontoid process of axis. 7 is the superior articular surface of axis. 8 is the body of axis. Then 9 is the pedicle and lamina of axis. Then 10 is the spinous process definitely. And 11 is the inferior articular process. Then 12 is the transverse process and foramen. The second cervical vertebrae C2 called the axis, projecting from its vertebral body is a spade-like process called the dens or odontoid process. The dens project superiorly through the anterior portion of the vertebral foramen of the atlas to form a pivot on which the atlas and head rotate. The articulation between the anterior arc of the atlas and the dens of the axis and between the articular facets is called the atlantoaxial joint. In some instances of trauma, the dens of the axis may be driven into the medulla oblongata of the brain, and this type of injury is usually cause of death from whiplash injuries. The third through sixth vertebral or cervical vertebrae correspond to the structural pattern of a typical cervical vertebra with a spinous process, 2 transverse processes, 2 superior articular processes, and 2 inferior articular processes. The superior and inferior articular facets of the cervical vertebrae C3 through C7 cervical vertebrae contact each other in the transverse plane. This articular orientation provides the neck region with a varied range of mobility, which includes lateral bending, forward and backward bending, and rotational movement, and as the articular surface slides over one another. The seventh cervical vertebrae, C7, called the vertebrae prominence, is transitional between a typical cervical and a typical thoracic vertebrae. Why? It has an unbifid large spinous process that resembles that of thoracic and may be seen and felt at the base in the midline of the back. That marks the end of our description about cervical vertebrae.